Welcome to Rges Pre-Algebra. This is lesson 26B, and we're going to be discussing sections 8.1 and 8.2. Now, this next week you will be having a test on chapter 6. So in addition to your review section, 6.14, that you'll be accountable for, by Monday, bring in all questions you might still have remaining on Chapter 6. We're skipping over Chapter 7 for right now, which has to do with finances, and we might look at that a little bit at the end of the course. But right now I'm going to be moving next into a geometry section in Unit 8. And so let me give you some overview ideas. Geometry is defined as the mathematics or the branch of mathematics that deals with the properties, measurements, and construction of flat figures, such as angles, triangles, and rectangles, and of solid figures, such as cubes, pyramids, and spheres. The word geometry comes from geo, the earth, and metra, or to measure the earth. Okay. It's a very old science. The most famous mathematician of ancient times was Euclid, about 1500 BC, and he wrote the book The Elements. He actually wrote that book around 300 BC, but the mathematics extends back to about 1500 BC, and that book, The Elements, is still used widely today. In fact, I actually studied it in college. So he begins, it's a delightfully well-constructed mathematics because he begins with a very brief, very small set of basic symbols and definitions and builds the entire mathematics one logical step at a time from that. Now, we won't be studying his very methodical approach to it, but we do want you to have the basic understandings of shapes, of areas, of circumference, of how to get, actually I don't know that we'll do the volume section, but we'll do these other things. So let's start with some definitions. A point is represented by a dot. Now, even though a dot here has a little teeny bit of size here, technically the real definition is that a point has no length, no width, no thickness. But to indicate a point on a piece of paper, we have to draw a teeny bit of thickness, right? So it's a location in space, and we always name it with a capital letter. So that is point A. A line extends infinitely in both directions. So here's a line, and imagine it as it goes infinitely in that direction and infinitely in that direction. It's named by using two capital letters, which are any 2 points on the line. Let's say we have this, and we would name that X and Y, so this would be line XY, and I would write it like this if I'm trying to reference it. I would just go like that with little arrows above it. Or we could name it by a small letter, and typically I see it on the end, they're writing it underneath. I guess it doesn't matter, but just not a capital, a small letter, and we would call that line M. Okay. You can, of course, be angling them in any direction, up, vertical, horizontal, oblique, at an angle like this. It doesn't matter. This is line L. Okay. If I can get an L. There we go. All right, a line segment is a portion of a line, and it has two endpoints, and we name it by the endpoints, like that. This is shown as a line segment. If we were to reference it on paper like this, we would just go AB with a line over it. That means line segment AB. A ray is a portion of a line having one endpoint and goes infinitely in the other direction. So if we draw something like this, it'd be like breaking a line in parts. You have the point on one side, and it goes infinitely in the other direction, and we would also write it, we'll take any other point on it, and we'll write this as, as ray AB. An angle is we have a endpoint and two rays coming off the endpoint. This endpoint is called the vertex. This would be vertex A. And we would call it angle. And we always put the vertex in the middle. So we could label this as B, angle BAC, or angle CAB. But we would never label this as the A, as one of the outside letters. Okay. The middle letter represents that is the vertex, and the two sides come off of that. So we could talk about the two sides of an angle. Occasionally we'll have something like this, and we would label it angle 1, and we would label this angle, okay, to name the angle, right? All right, now we could also name it just with the vertex, angle A. Okay. Let's talk about intersecting lines. I obviously haven't given myself enough room here. Let me adjust that a little bit. If two lines cross each other, they will have one point of intersection right there. And let's say this is line AB and line CD. Okay. And let's say they intersect at E, point E. Two lines will either have three possibilities. They will either, let's say this is line M and this is line L. They will either intersect at one point, or they will be parallel to one another. I guess we'll talk about that in just a second. I'm getting a little ahead of myself. To be parallel means the lines, they both go infinitely in both directions, and they never cross. Like, well, I would say like railroad tracks, but, you know, technically, railroad tracks do not go on forever. Okay? So intersecting lines cross at one point. Parallel lines, and notice how we spell that with the two L's. I always think of like railroad tracks in there. Okay, parallel lines. So you want the two L's together, not at the end, but in the middle of the word. They're lines in the same plane that never intersect. They have equal distance between them at all points. That means this little distance right here, whatever it is, let's say it's x, would be the same as this distance, is the same as this distance all the way across. If we wanted to write this, let's say this is L, line L, and this is line M, we would write L is parallel to M, and that's how I'd read it. Line L, because of a non-capital letter, represents a line. Line L is parallel to line M. One more idea. We can talk about a plane. A plane is a flat surface that extends infinitely in all directions. Now, we don't draw arrows everywhere, but you want to think about this as going infinitely in all directions, just spreading out. We could think of it like a flat wall in a room, but it just keeps going and going and going, or the floor or the ceiling, okay? A desktop is part of a plane. A parallelogram, such as the one below, is used to represent a plane. So this is how we always draw it this way when we want to represent a plane. And I believe they put it just a capital letter in the corner. They don't have that in your text, but so a capital letter by itself could represent a plane, or it could represent a point, okay, by context. Now let's take a look at some of the things you might be asked to think about. So I might give you a symbol like this, and you would tell me what that means, how I would interpret that in words. And I would write angle ABC. Or I might say, and you would write line segment. So it's just interpreting these symbols, trying to remember what is what. Line segment. I could do it in reverse. I could say I want you to write a symbol for ray PQ, and you would simply write the PQ with the ray sign above it. Only the arrow in one direction, because a ray has one endpoint, and the endpoint, of course, would be P, not Q. If I wanted to write PQ and I wanted my endpoint to be Q, I would have to write it that way. Let's see. We can talk about lines. We can talk about lines being horizontal. We could talk about lines being vertical, straight up and down. Mine's a little angled. And we can talk about lines being on the angle or oblique. Looking. Remember, when you have a triangle, or I'm sorry, an angle here, this is the vertex. The endpoint of the two lines is called the two rays, I should say, is called the vertex. Okay, I think you should be able to do 8.1 very easily. And then 8.2 has to do with plane shapes, geometric plane shapes and curves. So let's talk just a minute about that. Actually, I think I'll just pause and do that next time, because we'll have a whole other tape to do before you have to do this section. So